Number guessing game you yourself can create as a mini project.
Hey everybody, in today's topic, I thought we would create a game of rock, paper, scissors. Now that we know how the random module works, let's begin by importing the random module. We will create some options. We will use a tuple. We're not going to be changing the options. So a tuple would be better than a list. We have three options: rock, paper, or scissors. I'll create a variable named player to store the player's choice. For now, I'm going to set this to be none, as well as a computer. Our computer is going to pick a random choice from these options: rock, paper, or scissors. In order to do so, we can use the choice method of the random module. Random.choice. Pick a random choice from options. Let's have the player enter in some input. Enter a choice: rock, paper, scissors. Then we will display the player's choice and the computer's choice. I'll use an F string, player, :space, the variable player. Let's copy that, paste it, then change player to computer. Let's see what we have so far. Enter a choice: rock, paper, scissors. So I pick rock, the computer picks scissors. Let's try it again just for good measure. I pick paper this time. The computer picks scissors. I pick scissors. The computer picks paper. Okay, we know that the computer is successfully picking a random choice from our options. Now, what if the player picks something that's not within this tuple, such as the gun? Well, we would want to stop that, right? We need the user to pick a valid option: only rock, paper, or scissors. I think what we'll do is that when we accept the user input, let's place it within a while loop. So indent this line. While. This condition is going to be kind of weird. While our player variable is not in our tuple options. Let's try this again to see what happens. I pick the gun. Enter a choice. All right, well, if I can't pick a gun, how about a sponge? Well, I can't pick that either. Rock? That works. Our condition is while the player variable is not found within our options. If the player doesn't pick one of these options, this while loop will continue forever. Once we pick something that's within our options, we then escape the while loop. Let's check some win conditions. Now, if the player is equal to computer, that means it's a tie. I will print it's a tie. I'll add a few else if statements. Else if the player is equal to rock, I'll use the AND logical operator, and the computer is equal to scissors. That means you win. Let's print you win. Let's add another condition. Else if the player picks paper and the computer picks rock, then you also win. You win. Else if the player picks scissors and the computer picks paper, then we will print you win. Else, if the player's choice is not the same as the computer's, and we don't meet any win conditions, that must mean we lose. Print you lose. Let's see if this works. Enter a choice: rock, paper, scissors. I pick the gun. Nope, I can't pick that. I pick rock. I pick rock. The computer picks scissors. You win. Let me see if I can lose. I'll pick paper. You win again. Scissors. I need to stop winning. I need to see if the lose condition works. Okay, it's a tie at least, but I need to lose. All right, there we go. I pick rock, the computer picks paper, you lose. What if the user would like to play again? Let's place all of this code within a while loop. Let's do so right about here. Now, I'm not going to write while true like I normally do. This time, I'm going to create a variable. Let's say running. Is our game running? I will set that to be true. While running equals true. Or we could shorten this to just while running. That's simpler. I will place all of this code within the while loop. To mass indent some code, just highlight all of the code, then press tab. Hey everybody, this is Bro from the future. I forgot to explain something. The reason I'm not setting the condition of my while loop to be true is that if you have a lot of code within a while loop, it can be really difficult to find where the break statement is. If I set my condition to be a Boolean variable such as running, it's a lot easier to find any instance where I use this variable. If I were to highlight it, we can see that running is found down here. If I need to change any instance of this variable and rename it to something, you can refactor. Let's rename running as maybe playing. Then I will refactor. So my variable running is now playing, and that change was made down here too. So it's a coding preference. Every time we start a new game, I will reset the player as well as the computer. Let's move these two lines into the while loop at the beginning. So when we start a new game, we will reset the player. The computer will pick a new random choice. So let's see what we have so far. Rock. I pick rock, the computer picks rock. It's a tie. Then we have to play again. So paper, you lose. Scissors, it's a tie. Now, what if we would like to escape the while loop? After our win conditions, I'm going to create a temporary variable. Let's name this play again. Then we will ask for some user input. Play again, question mark, y/n, meaning yes or no. If the user types in something that's capital, I'm going to use the lower method to make it lowercase. So if our play again variable is equal to y, we would like to escape. What I would like to do is I would like to see if the player types in something that's not y. I will precede this condition with the not logical operator. If the user does not want to play again, then let's take our Boolean variable running, normally it's true, and set that to be false. Running equals false. And that means we will escape the while loop. Once we escape the while loop, I will print thanks for playing. Now I'm gonna change this momentarily. I just want to test it. Rock, play again, yes. Paper, play again, yes. Scissors, you lose, play again. Nope. Thanks for playing. This is entirely optional. I try and create as few variables as possible. I would personally rather avoid creating a variable here. Another way in which I could write this is that I can get rid of this variable. Let's move if not in front of the input and follow our input here, then use the comparison operator. Then add a colon. If the user's input, after making it lowercase, does not equal a y for yes, set running to be false. So that should work the same. Rock, play again, yes. Enter a choice. Paper, play again, no. Thanks for playing. This line would work the same, but it's a little more complex for beginners to read. Or you can use the other method that I showed you. All right, everybody. Well, that's a game of rock, paper, scissors. Hello everybody, today we will be creating a dice roller program in Python. We will be utilizing some ASCII art. I'll post all of the ASCII art that we'll need in the description of this video. You can copy and paste it to save time if you'd like. Alright, let's get started everybody. We will begin by importing the random module because we will be rolling some random numbers between 1 through 6. Hello everybody. If we're going to create some ASCII art, we'll be utilizing Unicode characters. To enter in a Unicode character, it really varies depending on your operating system. I think the easiest way would just be to use Python. To enter a Unicode character, type a /, then a given code for each character. Here are all of the codes that we'll need. After writing these 7 Unicode characters, let's run this program. These symbols that are output, let's copy them. I'll add them to a comment. Then we can delete this line. These are the Unicode characters we'll need to build some ASCII art, some dice. Each die will be made out of 5 lines. Let's begin with the first. We'll need a left corner, 9 dashes, then the right corner, vertical dash, and add out a beginning, main, start. Our dictionary is made out of key value pairs. The value will be a tuple. It's a dictionary made out of key value pairs where the value is a tuple. Within the tuple, let's add these lines, each separated with a comma. Form a point here. Paste it points. This dictionary of dice art. Each key is a number. Each value is a tuple made of strings. Let's create a list of dice. Our dice will be numbers, randomly generated between 1 and 6. A total, to calculate the total, I'll set that to be 0. Then we will ask a user for a number of dice. This will be some input. How many dice? Then typecast the input as an integer. We don't want somebody to write, 2.5 dice. You can't roll half a die. To generate a random number, you can use the randint method of the random module. We need a random number between 1 and 6. Then we need to append this number to our list of dice. Dice.append. Then we can move this line to within the append method. We need to do this a number of times depending on how many dice the user enters in. We can place this line within a for loop. For every die in our range, number of dice. This will be a number. Let's print our list of dice to see what numbers we have in here. How many dice? I would like 5 dice. 5, 3, 3, 4, 6. Okay, we know that that works. Let's calculate a total. We'll need to iterate and sum all of the elements within our list. We can do that with the for loop. For every die in our list dice, take our total variable plus equals the current value within our dice. Then we will print a total. I'll use an F string, total colon space, our total variable. Let's see what we have so far. How many dice? I would like 5 dice. Our total is 19. Now between these two for loops, we will display our ASCII art. The easiest way would be to create some nested for loops. The outer for loop will be in charge of the number of dice. For every die in our range, number of dice. The inner for loop will be in charge of printing every tuple. For every line in, then to get a value in our dictionary, we would type the name of the dictionary, dice art, then use the get method. What are we getting? We're getting a value at a given key. Let's take our list of numbers, dice, at index of die, our counter. Depending on what the user types in for the number of dice, die will begin at 1, then increment. Within the inner for loop, we will print the line. So let's take a look. How many dice? I would like 3 dice. And here's our ASCII art. 6 plus 2 plus 4, that equals 12. If you would prefer, we can display all of these dice on a single horizontal line instead of one vertical line. It's a little more tricky though. If you would prefer that approach, let's turn this chunk of code into comments. We will write this nested loop a little different. So each tuple is made up of 5 elements, right? So if we're printing a horizontal line, let's say we roll the numbers 1 through 3. We would first need to display this line of the first dice, then the first line of the second dice, then the first line of the third dice. During the next iteration of the outer loop, we would display the second line of the first dice, the second line of the second dice, the second line of the third dice. So it's a little more complex. Let's create an outer loop that will iterate 5 times. For every line in range 5. Then the nested loop will be for every die in dice. How many dice do we have within our list? We will print. We're going to get one of the values found at one of the numbers that we roll. Take our dictionary of dice art dot get, then a number 1 through 6. That will be the value found within our list of dice. Get the current die. Remember that this is a number 1 through 6. We would then need one of the elements found within our tuple. So get the first line, then the second line, third, fourth, fifth. So let's add the index operator. Place our counter of line within the index operator. Let's see what we have so far. We need to add one more thing. How many dice? 3. This is an abomination. There's one more change we need to make. At the end of our print statement, let's set the ending character to be an empty string. And that should fix that. How many dice? 3. Okay, we're getting better results. Then when we escape the inner loop, we will print a new line. How many dice? 3. And there we are. 3 plus 6 plus 1 is 10. All right, everybody, so that is a dice roller program. It is kind of complex, but I thought this might be a good exercise. If you would like a copy of this code, I will post all of this in the comments section down below. And well, yeah, that's a dice roller program in Python. Hey everybody, today I need to explain functions. Think of a function as a block of reusable code. To invoke a function, you place a set of parentheses after the function name to invoke it. Here's a scenario. I need to sing happy birthday 3 times. I know it's a weird example, but it makes a lot of sense. Just trust me on this. If I need to sing happy birthday 3 times, I would write something like this. I'm going to create my own version of the happy birthday song. This is one verse. If I need to repeat this code 3 times, without using functions, I could either repeat this code, or maybe place it within a loop. So here's my happy birthday song 3 times. But there's a better way of handling this that doesn't involve repeating our code or using loops. What if I could write this code once, then reuse it whenever I need to? That's where functions come in. To define a function, you would type def, then a unique function name. Let's name this function the happy birthday function. Add a set of parentheses, a colon, any code that belongs to the function you'll want to indent underneath. Then to invoke this function, I would type the name of the function, happy birthday, add a set of parentheses, and that's it. When you invoke this function, you will execute this code once. If I need to execute this code 3 times, I would just call it 2 more times. Happy birthday, happy birthday, happy birthday. To invoke a function, you type the function name, then add a set of parentheses. I like to think of the parentheses as a pair of telephones talking to each other. You call a function to invoke it. Hey, happy birthday function, execute your code. With functions, you are able to send data directly to a function. Using what are known as arguments, you can send values or variables directly to a function. Place any data within the set of parentheses. I'll send my function a first name. Any data you send a function are known as arguments, but you need a matching set of parameters that are in order. What exactly is the data we're sending in? Well, it's a name. I will add one parameter, are known to hey, happy birthday function, execute your code. With functions, you are able to send data directly to a function. Using what are known as arguments, you can send values or variables directly to a function. Place any data within the set of parentheses. I'll send my function a first name. Any data you send a function are known as arguments, but you need a matching set of parameters that are in order. What exactly is the data we're sending in? Well, it's a name. I will add one parameter to my happy birthday function. I will name this data name. A parameter is kind of like a temporary variable that's used within a function. I'm going to replace this instance of u with a name. I will use an f string, replace u with a placeholder. I will add my parameter name. So happy birthday to bro. We could pass in some other names. What about Steve and Joe? Here we are. Happy birthday to bro, happy birthday to Steve, happy birthday to Joe. When you invoke a function, you can send more than one argument. Let's send an age this time. I'll send 20, 30, and 40. But when I run this, we have an error. We're passing in 2 arguments, but our function is set up only to take 1. I would need a matching number of arguments. To invoke this function, we will need 2 parameters. We have a name and we have an age. Then let's use this age. You are, let's make this line an F string, age, years old. Let's try that again. Happy birthday to bro. You are 20 years old. Happy birthday to Steve. You are 30 years old. Happy birthday to Joe. You are 40 years old. When you invoke a function, you can pass in some data. Those are known as arguments, but you'll need a matching set of parameters. The order does matter. Let's see what happens when I switch these 2 parameters. Age, then name. Happy birthday to 20. You are bro years old. Happy birthday to 30. You are Steve years old. Happy birthday to 40, you are Joe years old. So the position of the parameters does matter. Same thing goes with the arguments. You also could name these parameters something unique. Maybe X and Y. Happy birthday to X, you are Y years old. That's also valid. Let's try another example. I'm going to create a function to display an invoice. There will be 3 parameters: a username, an amount, and a due date. Let's print hello. I should make this an F string. Username. We'll use another F string. Your bill of amount. Let's precede this placeholder with the unit of currency. I will also add a format specifier. Point to F is due on our due date, whatever that parameter is. To invoke this function, we will type the function's name, add a set of parentheses, a username, an amount, and a due date. Let's make up some username. An amount, I guess $42.50. I'm just making up a number here. Then a due date, the 1st of January, I guess. Here's my invoice. Hello, bro code. Your bill of $42.50 is due on January 1st. Let's change these arguments. Joe Schmo is the username. He owes $100 and $1. Due on the 1st of February, or January 2nd, depending on how you read dates in your region. Hello, Joe Schmo. Your bill of $100.01 is due on 1/2. That's another example. Now we need to explain the return statement. Return is a statement that is used to end a function and send a result back to the caller. Here's an example. We have a variable z. Z will equal. We'll invoke a function to add 2 numbers together, such as the numbers 1 and 2. When we invoke a function, we can send some data back. After adding 1 and 2, we will send the result, which would be 3. Then this value can be assigned to a variable. Then we can print whatever z is. So let's create some functions. Let's create a function to add 2 numbers together. The parameters will be x and y. Let's say z equals x plus y. Then we will return our value z. So I'm not going to print z directly right now. Let's subtract x and y. Subtract z equals x minus y. Return z. Multiply x times y. Then divide. X divided by y, return z. Let's invoke our add function, pass in 2 numbers, 1 and 2. Then I'm going to print the result. After adding these 2 numbers together, the result is 3. What about subtract? Subtract 1 and 2. The result is -1. Multiply The result is 2. Then divide. 1 divided by 2 is 0.5. After we resolve this function, a value is returned. Just imagine that after we finish this function becomes whatever is returned, 3. This function becomes -1. This function becomes 2. This function becomes 0.5. Let's write something a little more complex. We will create a function to create a full name. Create name. We'll need 2 parameters for a first name and a last name. I'll name these first and last. What do we want to do within this function? Let's capitalize the user's first name. First equals first dot capitalize method. Then do the same thing with the last name. Last equals last dot capitalize. Then I'm going to return the user's first name plus their last name. Then I'll add a space in between their first and last name. This is also valid. Outside of the function, let's create a full name variable, then invoke the create name function. So this function is going to capitalize the first and last name for us. I'll type in my first name, all lowercase, same thing with my last name. Then let's print our full name. And here's my full name variable. We sent our function some arguments. We have some parameters set up. We took those values, made them uppercase, then concatenated these strings together, then returned them as a single string. Let's try this with a different name. SpongeBob SquarePants. SpongeBob now has a full name. The first and last names are now capitalized. Using the return statement, you can return some data back to the place in which you call a function. Well, everybody, that's a function. It's a section of reusable code. To call a function, you type the function's name, add a set of parentheses. You can send a function some data, which are known as arguments, but you'll need a matching set of parameters. You also do have the option of returning some data back to the place in which you invoke a function. We'll be using functions a lot in the future, but we will get more practice with them. And those are functions in Python.